We're going to continue with chapter 5, and we're going to discuss graphing inequalities. So we're kind of moving out of the systems of equations mentality that we've been in, and we're going to look at a different topic, which talks about graphing linear inequalities. So let's take a look at that. So the idea in this particular lesson is that we're no longer graphing a particular line. We're graphing an inequality, which means that we're going to be looking at an entire region that's going to be a solution to our equation. So you want to keep that in mind. So the first example that we're going to be looking at is to determine whether or not the ordered pair is a solution to the given inequality. And similar to when we were looking at is that particular ordered pair a solution to an equation, we're going to solve these in the exact same way. So we're going to take that value, that ordered pair, and we're going to plug it in. We're going to plug in the x and the y into our equation to see if we end up with a true statement. So if we plug in our x value, we're going to have 2 times negative 1 plus my y value of 9 is less than negative 3. Have to know your inequality symbols. Make sure we know that that's a less than symbol, and let's see if we end up with a true statement or not. 2 times negative 1 is negative 2 plus 9. Is that less than negative 3? Negative 2 plus 9 is a positive 7. 7 is less than negative 3. This is not a true statement. This is a false statement, and therefore negative 1, 9 is not a solution. Let's look at our second example. Take that 2, plug it in for x. Take that negative 2, plug it in for y. You're going to get 2 minus 3 times negative 2 is greater than or equal to 8. 2, negative 3 times negative 2, it's a negative times a negative, so it's going to be a positive. Positive 6 is greater than or equal to 8. You get 8 is greater than or equal to 8. Well, because we have that equal to symbol as a part of our inequality, this guy right in here, this ends up being a true statement. So this is a true statement here, and therefore 2 comma negative 2 is a solution to this inequality. Now I want to show you just what the graphs of these inequalities look like, and to kind of further illustrate this. So we're going to head to Desmos. We're going to graph 2x plus y is less than negative 3. So 2x plus y is less than negative 3. And you'll notice here a couple things that are going to come into play. Notice that this is actually a dotted line. And notice that this entire region in here, any ordered pair in this region, and it goes on forever and ever, is a solution. So for example, negative 20 comma negative 10 is a solution here. Okay, negative 40, 0 is a solution. Negative 20 comma 5 is a solution. 20 comma 5 is not a solution. All of these points are solutions. So if we look at what we were asked about, which was negative 1 comma 9, I zoom in here, and I go to negative 1, which is right here, up to 9, which is right here. Notice that it's not in the shaded region, and therefore it is not a solution. Okay? We can do the same thing for our second graph. X minus 3y is greater than or equal to 8. We get rid of that. X minus 3y is greater than or equal to 8. And if I look at that graph, and in that graph I was looked at the point 2, negative 2, and notice that the point 2, negative 2 is exactly on that line. It's exactly on that line, and therefore it is a solution. Notice that this was a solid line, my other graph was a dotted line. We're going to talk about how we know both of those things as well. Okay, so you can use the graphs to help you. Let's head back to the notes. Couple key things here when we're actually graphing these. Now, obviously, you have a luxury right now of using Desmos, but you are expected to know how to graph these by hand. So first of all, How do we determine if it's a dashed or a solid line? Well, it's very similar to that concept of open and closed circles. So we use a dashed line when we have either just a less than or a greater than symbol. And a dashed line means that the points that are actually on that line are not solutions to that inequality. We use a solid line when we have the less than or equal to or the greater than or equal to. And in those cases here, those points on the line are solutions to the inequality. So the first thing you want to determine is it a dotted or a dashed or a solid line? And that's based on whether or not you have the equal to symbol. The second thing, and the notes here describe one way that you can do to determine, is which way to shade. I like to think of it as either shading above or below the line. So when we have a greater than or equal to symbol, we're going to shade above the line. The strategy that the notes here are saying, and this is really important, what I'm writing here, is to use a test point, which is perfectly fine. You can use a point and determine if it's a solution. I like to just think of shading above or below. If I have a less than or equal to, I'm going to shade below the line. This is very important. Make sure that you write this down as well as step 1. Steps 2 and 3 are giving you techniques to determine which way to shade in another way, but again, I like to think about it as shading above or below the line. So let's take a look at an example here. We have y is less than or equal to 2. So what we're really graphing here is we're graphing the line y equals 2. So we're really graphing this line, y is equal to 2, which if hopefully you're remembering is a horizontal line at 2. So I always say to myself, okay, am I going to deal with a dotted or a dashed line? Well, I have the equal to symbol. So the equal to symbol right here tells me that I'm going to have a solid line. So I'm going to make a little note to myself, okay, I'm dealing with a solid line. Am I going to shade above or below? Well, I have a less than symbol. So because I have a less than symbol, I know I'm going to shade below. So we have a solid line at y equals 2. And I'm going to shade in the region below that, in this area in here, meaning that any ordered pair in that shaded region is a solution to my equation. So for example, the point right here is a solution. That point of whatever it ends up being, in this particular case, it's -4 comma -3, is a solution. Any point in that red shaded region is a solution. All right? Let's look at our next example. Y is less than or equal to 2x plus 1. So what are we graphing? We're really graphing the line y equals 2x plus 1. Again, because I have this symbol, it's going to be a solid line. So it's a solid line. And I know, again, I'm going to shade below. So now we have to remember how to graph. Begin at your y-intercept, which is at 1. My slope is 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Or I can go down 2 and left 1. So here's my line. And now I have two options. I can either shade here in region 1 or here in region 2. Well, region 1 is above the line. Think about what is above that line. That is region 1. Region 2 is below the line. So I'm going to shade now in this region down in here. And that is my solution. Any ordered pair in that region is a solution to this particular inequality. Let's keep going. Graph negative x plus 2y is greater than 2 in the coordinate plane. Well, now in this particular case, my equation's not solved for y. So step 1, we have to solve this equation for y. So negative x plus 2y is greater than 2. I'm going to add my x to both sides. That's going to cancel. I'm going to get 2y is greater than x plus 2. Going to divide everything by 2 to get y by itself. Y is greater than x over 2 is just 1/2 x. And then 2 over 2 is a positive 1. Don't decide whether your line is going to be shaded above or below till you get that equation in slope-intercept form. So we're really graphing the line y equals 1/2 x plus 1. Now this particular case, I know I'm going to have a dashed line because there's no equal to symbol. And I'm going to shade above because it's a greater than. Let's graph the line starting at 1. Slope is 1/2, so up 1, right 2. Or I can go down and to the left. Here's my line. It's a dashed line. So make sure you've got it as a dashed line. And we're going to be shading above. So I'm going to take this and I'm going to shade above the line, which would be in this region in here. Meaning any ordered pair above here is a solution. Now, the points on this line are not solutions here. Unlike in this example where we had a solid line where those points are solutions, in this example we have a dashed line and the points on the line are not solutions. One more example. Again, we have to get this into y equals mx plus b form. So we've got negative 2x minus 4y is greater than 8. We're going to start by adding the 2x to both sides. Now you've got negative 4y is greater than 2x plus 8. Divide by negative 4. Uh-oh. Alarm bells should be ringing here. We're dividing by a negative in an inequality. Remember, your inequality rules still hold. So you have to flip the sign when multiplying or dividing by a negative. So here, we divided by a negative 4. I have to flip that inequality sign to a less than. Y is less than negative 1/2 x minus 2. So now we're going to have a dashed line, and we're not going to shade above the line because I have a less than symbol here now. So because I have a less than symbol, I don't want to use red. I'm going to shade below this line. So let's go ahead and graph this. Y-intercept is at -2. Slope is -1/2. So I can go up and to the left. Or I can go down and to the right. It's going to be a dashed line. And I'm going to shade below. So everything in this region down in here is a solution. All right, so the key things here, make sure that you are understanding whether it's a dashed or a solid line, and make sure whether you know whether to shade above or below. So just to go back to those initial slides there, remember we determine if it's a dashed or a solid line based on whether or not it's an equal to or not equal to. And we decide whether the shade above or below based on being greater than or less than. We'll look at a word problem in class as well as several more examples. I'll see you then, guys.